Fertigation. Fertigation is a method of applying water-soluble fertilizers simultaneously with irrigation. In recent years, drip irrigation became widespread, and an increasing number of hectares are equipped with fertigation systems. This method of delivering mineral fertilizers has its specific advantages and disadvantages. One of the main advantages is an improvement of crop yields and product quality. Thanks to drip irrigation, plants do not suffer from a lack of moisture. Fertigation requires an excessive automation of processes but helps reduce the time and labor inputs of human operators. As the fertilizer is applied as solution, nutrients are in a form accessible to plants. Another advantage is the fact that water and available nutrients are delivered to the main intake zone of the root system. During fertigation, a plant is fed continuously throughout the development period, which prevents any disruption in supply of nutrients. Continuous feeding makes it possible to adjust the nutrition system at any stage of development of a crop. It also becomes possible to maintain the required content of nutrients in poor soils. Modern agriculture dictates an efficient use of mineral fertilizers. Fertigation helps increase fertilizer utilization efficiency, minimize cost overruns through a better control of environmental loads, and reduce the loss of nutrients with washouts and non-exchange binding. A drip irrigation system allows farming machines to make fewer field runs, thus reducing mechanical compaction of soil. Also, in comparison with other water techniques, drip irrigation allows plants to use moisture more efficiently, prevents water erosion of soil, saves significant amount of water, lowers the risk of plant infections, and reduces weeding. With the drip technique, a correct amount of fertilizer can be delivered regardless of weather conditions or farm organization. However, fertigation also has a number of disadvantages. Delivery of fertilizers by means of drip irrigation requires proper conditioning of irrigation water. Also, a fertigation system will require significant upfront expenditures. The composition of the master solution has to be checked carefully, as not all mineral fertilizers are mutually compatible. Only fully water-soluble fertilizer can be used in fertigation. A fertigation system can have different configurations. A typical layout is as follows. Master solution tanks are used to dissolve and divert fertilizer into the irrigation system. Preparation of feeding solutions takes place in tanks A and B and also in AC tank C. An injector is used to proportionally and evenly add a master solution to irrigation water. Irrigation water is pre-treated in filtration systems. The flow of water passing through the injector creates a negative pressure that directs the feeding solution into a channel, where it is mixed with irrigation water and injected into the irrigation system. The water flow is regulated by a shut-off valve. Fertilizers achieve optimal concentration in the main pipe, from where they are delivered to plants with irrigation water. Drip tails distribute the feeding solution across the entire irrigation area. Use of fertigation imposes a number of preconditions. Firstly, there are certain requirements to the equipment part of the system. For instance, optimal pressure has to be maintained across the whole drip irrigation system. It is also necessary to have a filter to prevent drippers from clogging with solid particles that may enter the irrigation system. Another requirement is the availability of a check valve. The drip irrigation system should be resistant to aggressive solutions. The fertilizers in the system should meet the plant's nutrition requirements. The fertilizers should have full water solubility. In other words, they should dissolve in water without precipitation. The fertilizer should not contain practically any impurities, especially harmful water-soluble salts. Irrigation water also has to be checked against certain parameters. Excessive hardness or presence of bicarbonates should be avoided. High mineralization in excess of 4 equivalent milligrams per liter may cause precipitation. Duration and completeness of fertilizer dissolution depend on water temperature. Excessive bacteria and waterborne particles can block the drippers and cause uneven irrigation or equipment failures. It is also necessary to monitor concentration of toxic elements, total mineralization and pH. In a fertigation system, fertilizers are fed in small doses during the main part of the growing season to match the nutritional needs of the plants. There are certain aspects to the preparation of the master solution. Different fertilizers have dissimilar degrees of solubility, and so the amount of water needs to be calculated correctly. Dissolution of fertilizers often causes a drop in water temperature. Accordingly, the solution preparation time has to be taken into account. However, dissolution of concentrated calcium nitrate actually produces heat, which may give this material a significant advantage. Another important consideration is the compatibility of solution components to avoid precipitation. For example, calcium nitrate cannot be matched with phosphate-based fertilizers such as monoammonium phosphate and monopotassium phosphate. To summarize, fertigation is an effective and resource-efficient cultivation technique. It has a number of advantages and limitations. If used correctly, it can achieve high yields and also improve the quality of agriculture products. Like with any open soil nutrition system, the design of fertigation programs should be based on an agrochemical analysis of soil and factor in the nutritional needs of specific crops.